Hey Shane, let's take a look at this fraction question that you sent me. So, as you mentioned, you know kind of how to solve it, just kind of by going through the process, which is good. The concepts behind this, very tricky wording I found on this question. So, while he's at the grocery store, Raymond purchased a box of candy for himself. So we can think of this as one. He has one box of candy right now. On the way back to residence, he ate 1/3 of the candy. Okay, so we're going to subtract 1/3 from 1. That's our first part. Okay, so when we do this, remember this is really like a fraction of 1, but that's no good. So we're going to have to multiply this fraction by 3/3 to get 3/3 minus 1/3 because we're subtracting, so we have to have common denominators. And if you punch this into your calculator, 3 divided by 3, we know that's 1. 1, so 3 minus 1 is 2. We leave the denominators, so that's 2/3, okay? So basically he ate 1/3 of the candy, which means he has 2/3 left. That should kind of make sense if we think about it, right? Like this is a box of candy, divided into thirds. He ate 1/3 of it, so we have 2/3 left. So that's cool. As he was putting away the groceries, he ate half of this. He ate half of what was left. So now we have 2/3, and we're going to multiply it by 1/2. Now, why am I multiplying? It's because we're going to take a fraction, and we're going to take a fraction of a fraction, which means we multiply. Okay? So when we multiply fractions, we just multiply top and bottom, or we could reduce as well. So we have 2/1 is 2, times 3/2, which is 6, and then the even half rule, let's take half of each, that's 1/3. Consequently, kind of the slick way of doing that, let me change my color. If we look in the diagonal, we have 2 divided by 2, that's 1. So we can just get rid of that, and we have 1/3 left. And then we're kind of already reducing it. All right, so essentially, that kind of makes sense too. So think about this. We have all the chocolates. This circle represents the whole box. 1/3 is gone, and now he ate half of what was left. So now he ate another third. So the only thing we have left is 1/3. Okay? So again, that kind of makes sense, 1/3. So now the last part, there are now 4 chocolates left in the box. How many chocolates were there to begin with? So he has 1/3 left times, we can call it C for chocolates, you could use X, and that equals 4. So now we're making an equation. We know there's 4 left in the box, so 1/3, what he has left, times the starting quantity, which we don't know what that is, so we'll call it C or any letter. That's our equation. Now we can solve the equation. So if we were to multiply this out, 1 times C/3, I could really just write that as C/3 equals 4 if you wanted to. This is just another way of expressing it. C is being divided by 3, so I'm going to do the opposite of that. I'm going to multiply both sides by 3. 3 divided by 3 is gone, and I'm left with C equals 4 times 3, which is 12. Okay? And that makes sense again. If you're starting with 12 chocolates, like let's just draw, we could draw 12 chocolates pretty quick. I'll draw them in groups of 3. Okay? Got 12 chocolates. So again, he ate 1/3 right off the bat. Then he ate half of what was left. So that was another third, and we're left with, 4 chocolates left. Okay, so visualizing fractions is a great strategy as well. But basically the big thing here I found is just the language. Okay, so he ate 1/3 of the candy. We're taking 1/3 away. Then he ate half of what was left. That means we're multiplying. Okay, but again, if you drew a picture, you could just take away another third. So fraction geekery, but I hope that helps. If you have any other questions, just let me know.